When it comes to the law of sines, there is something called the ambiguous case. In this video, I'm going to look at the ambiguous case where we get only one triangle as a solution. So, going to solve the triangle ABC, where angle A is 45 degrees, side A is 7 root 2, and side B is just 7. So I can get angle B using the law of sines in this information here. So I'm going to have sine of 45 over 7 root 2 is equal to sine of B over just 7. Now I'm going to solve for sine B by multiplying the 7 over. So I'm going to get 7 sine of 45 over 7 root 2 equals sine B. And then I need to solve for B, so I'm going to take the arc sine of both sides, and you can actually cancel out the 7s if you want to, or leave them in as if you feel like it. Not wrong either way. But regardless, I'm going to take the arc sine of both sides. So arc sine of sine 45 over square root of 2. I decided to simplify. And it's going to give me B. Now when I plug this into my calculator and make sure you're in degree mode and not radian, we're going to get B equaling 30 degrees. So angle B is equal to 30 degrees. Now, I still need to find angle C and side C to complete my triangle. So angle C is very easy. Just going to take (180) and I'm going to subtract 45, what A is, and subtract 30, what B is, and that's going to give me 105 degrees for angle C. So C is 105 degrees. Now, I can use the law of sines and angle C to figure out side C. And I'm going to stick with using A because that just seems like the easiest thing for me to do. So, sine of 45 over 7 root 2 is equal to sine of 105 over C. Now I'm going to solve for C. I'm going to multiply the C over, divide the sine 45 over, and multiply the 7 root 2 over. And I'm going to end up with C equals 7 root 2 sine of 105 over sine of 45. And when I plug this into my calculator, again, make sure it's in degree mode, C is going to equal 13.5. So there is my final side, and this completes my triangle for this question. But you may be asking, well, how do I know there's only one triangle? Is there a way to prove it? There's a couple ways you can go about it. We look at this table and see that it says one triangle. A is less than 90 degrees, which it is, and A is greater than or equal to B. Well, A is definitely greater than B, so this makes it true. But again, let's say we're not 100% sure, you don't have this memorized. How can we go about it logically? Well, let's say you believe that there's two triangles. So let's find the second triangle. And we would do that the exact same way we'd find another triangle, is we would just take angle B for the second one, and we would do 180 minus 30, because that's what angle B is, and we would get 150 degrees for angle B. Now, how will we get angle C? Angle C is very simple. We would again do 180 minus 150 minus 45, because that is what angle A is. And that's going to end up giving us a negative number, right? I think it's going to be negative 15 degrees. Not going to work, not possible. You can't get a negative angle measurement within a triangle. That is just not going to happen. So that would be the second way you can prove that there is no second triangle for this question. Only the one we solved for.